Space is often described as empty, but some regions are anything but. There are places where gravity becomes absolute, where motion has only one direction, where the universe no longer allows return. This is not science fiction. This is a real structure predicted by astrophysics, observed through space technology, and studied by NASA and modern space documentaries. This is the boundary of a black hole, and beyond it, something fundamental changes. A black hole begins its life quietly. When a massive star runs out of fuel, gravity wins. The core collapses inward, not gradually, irreversibly. What remains is an object so dense that space itself curves toward it. Matter follows, light follows, time follows. From a distance, a black hole appears simple. It has mass, it has spin, it has charge, nothing more. Yet that simplicity hides the most extreme behavior in the known universe. At the center of every black hole is a boundary called the event horizon. This is not a surface. It is not a wall. It is a point of no return. Once crossed, no signal can escape. No message can be sent outward, not even at the speed of light. From the outside, nothing dramatic seems to happen. An object falls. It slows. It fades. Time appears to stretch it thinner and thinner until it freezes at the edge. From far away, the crossing never completes. But this is an illusion created by gravity. For the falling observer, time behaves very differently. There is no sudden alarm, no visible barrier. The event horizon is silent. Physics does not announce the moment. Space does not resist. The crossing happens without sensation. And once it does, the universe removes every familiar option. There is no path that leads back. Not because escape is forbidden, but because escape no longer exists as a concept. All future directions point inward. Inside the event horizon, space and time exchange roles. What once was movement through space becomes movement through time. The center is no longer a destination, it is a certainty. No force can stop the fall, because falling is no longer motion, it is progression. This is not destruction in the ordinary sense, it is redefinition. As descent continues, tidal forces grow. Gravity is no longer uniform. It stretches and compresses unevenly. Atoms separate. Structures dissolve. This process is known as spaghettification. But even here, there is no violence, only inevitability. The black hole does not act. It does not attack. It simply allows gravity to complete its equation. Time, meanwhile, loses coherence. Clocks slow. Sequences blur. Cause and effect weaken. Events that once followed order begin to overlap. From the outside universe, billions of years may pass. Inside, only moments remain. Astrophysics predicts this behavior with unsettling precision, yet prediction ends quickly. Beyond a certain depth, no theory agrees. General relativity breaks down. Quantum mechanics offers no clarity. Even the mathematics grows uncertain. At the center lies the singularity, a region where density becomes infinite and known laws collapse. This is not a place we can describe. Language fails. Equations diverge. Science does not claim understanding here. It records the limit and stops. And still, black holes are not rare. Nearly every galaxy contains one. Our own Milky Way is anchored by a supermassive black hole 4 million times the mass of the Sun. It does not threaten us. It does not notice us. It shapes the galaxy quietly over cosmic time. Through space technology, humanity has begun to observe these objects directly. The Event Horizon Telescope captured the first image of a black hole's shadow, not the object itself, but the absence it creates, a dark region outlined by distorted light. This image was not dramatic. It was calm, blurred, almost modest, and yet it confirmed decades of theory. Modern observatories track black holes by their influence. Stars orbit invisible centers. Gas heats and spirals inward. Jets of energy stretch across galaxies. None of this is chaotic. Black holes obey the same physical laws as everything else. They simply explore those laws to their final extreme. Organizations like NASA study black holes not for spectacle, but for understanding. They test gravity, they test space-time, they test the limits of knowledge. Even SpaceX and modern rocketry contribute indirectly, launching instruments that extend human perception beyond Earth. Each mission adds clarity and also restraint. The more we learn, the more defined the boundaries become. Black holes do not reveal answers easily. They reveal scale. They remind us that the universe is not designed for observers. It does not adapt to comprehension. It does not simplify for survival. Human history occupies seconds on a cosmic clock. Black holes evolve over billions of years, unaware of civilizations, languages, or meaning. Inside the event horizon, information may be lost forever, or it may be preserved in ways we cannot access. Physics has not resolved this. What is clear is that crossing the boundary removes the observer from the shared universe, not erased, not destroyed, simply disconnected. This is the quiet truth that space documentaries often circle but rarely state plainly. The universe does not oppose us. It does not welcome us either. It continues.
A black hole does not end existence. It removes context. Beyond the event horizon, there is no audience, no reference frame, no return. Only continuation towards something that cannot be described, measured, or remembered.
And perhaps that is the most unsettling realization. Not that the universe is dangerous, but that it is complete without observation. That even the most extreme boundary in nature does not announce significance. It simply exists. This has been Astro Files.